Hey guys, just a quick announcement before the video starts. I made a new Discord server. Make sure you join it for announcements and updates to things that you might not see on this YouTube channel. What's up guys, it's your boy Justin and welcome back to a little programming tutorial. Um, Today we're going to be talking about SafeRequest and how you can implement it into a project of your own and how it can protect transmissions of data over HTTP between a C# client side and a PHP server side. So I'm just going to quickly make a solution, put on my desktop. We'll just call it SR test for SafeRequest test. If you've used NuGet before, installing it will be pretty easy, but regardless, it's just like it takes like 10 seconds. So you're just going to click on Tools at the top, go to NuGet Packet Manager, Manage Packages for the solution, click on Browse, and you're going to search up SafeRequest. You see it pops up here. Click on the little checkbox and click install. You can see it's on version 1.1.2 right now. Whenever I make even like small changes, I usually push it to the NuGet. So even if there are substantial changes in the version number, it'll probably function very similarly. So this tutorial should last. So now that we've installed it, first of all, let me just write using SafeRequest, and because I want to show you what a default request will look like in comparison, I'm just going to also use system.net. So first of all, let me show you what a normal little, let's just say we're retrieving a variable from a server, so we're just going to do a little get request essentially, and just get a string from a PHP script, which outputs a string to us, and we'll go ahead and look at how that works without SafeRequest. So first I'm going to initialize a web client. In my situation, I'm also going to go ahead and add a user agent header just because my server works in a weird way and it will deny requests that don't have a user agent. So this doesn't really matter. You probably won't have to do this, but let me just write example. This isn't actually a SafeRequest. And we're also going to go ahead and I guess just do a little get request. So I have this URL right here where I'm going to host these files for testing purposes. So I'm going to create a new file and we'll just call it, I don't know, I guess test.php, why not? And open that up. So let's just say I want to get the variable testing123, so I'm just going to save that. And you should have that now. You see if you visit from the browser, testing123. So we're going to go ahead and send a request, a download string, which is a get request, and see what we get. So data equals web.download string from that URL, console.writeLine data, and console.read key. So now we can see that we're able to get testing123, whatever. You can see it has HTTPS. You can see the certificate's valid, connection is secure, so your data is encrypted by SSL and your certificate. However, tools like Fiddler, little web debuggers here, are actually capable of decrypting SSL traffic, and you can see there's an option right there. The way this works is it will basically have its own proxy that's replaced in your request, and it's like a little middleman. So when the data is retrieved or sent, whatever the case may be, it can automatically decrypt data by using the certificate as your computer normally does, or as your browser usually does whenever you make a request. So that's kind of the whole entire concept of these web debuggers that can actually decrypt SSL data automatically. And so if we go ahead and run the program, we're going to notice in Fiddler this pops up, and even though it's sent with protocol HTTPS, we're going to be able to see in text view testing123, which is obviously not ideal. And so SafeRequest is basically how you would combat this by adding your own layer of encryption on top of the default encryption provided by SSL, so that's using an automated tool such as Fiddler, and there are many alternatives, is not enough to actually see what's going on between your client and your server. So start using SafeRequest. Go ahead and create an instance of the class, and we'll just call it SafeRequest. And there's only one parameter that you need to pass. It is a string, which will be used to derive an encryption key from that. So that directly is not the encryption key. The string will be hashed, and then bytes will be derived from the hash, which will work as the encryption key. But I'm going to add support for secure string very soon, which will essentially allow you to uh, put your characters one by one into an immutable object in memory, which is encrypted, provided by .NET. It's built in. That'll come at a later date probably, but it's not that important, and I'll talk about why later. But first of all, put like pick a little key. I'll just make my key test. This will have to match up client side and server side, obviously. And that's as far as that goes. What you're gonna want to do is open up your solution. All right, go to the root directory of it right here. Click on packages, and in the SafeRequest directory, there's going to be a PHP script right here, SafeRequest.php. And this is going to contain the SafeRequest class, as you can see right here. Nothing too big going on here, but it's just basically handles the encryption and decryption server side. So I'm going to go ahead and put this on my server, as you will also do. And I'm going to edit test.php. So we're going to go ahead and require that we have that file here. And then we're going to create an instance of the SafeRequest class in PHP. So I'm just going to call it SafeRequest so that it matches my client. And we're going to say new SafeRequest. And we're going to pass that key. And so like I said, test. That's what we use on the client. It's got to match up the server. And now we want to send test 123 or testing 123 to the client. So outputting data works a little bit differently in SafeRequest. There is a function called output, and it has a bare minimum. It'll accept a Boolean representing whether or not the request is successful, and a string representing the message. So I'm going to go ahead and say SafeRequest output and a Boolean. So this is going to be true because we are able to successfully send data to the client. And testing 123. Now, when this might be false is, for example, if you wanted to make a login system, and that's what you're setting up right now, and they didn't log in successfully, you would have false right here, and then on the client, I'll show you how to check that in a minute. It would be much easier to handle information because the client automatically parses it and decodes it for you, even when you pass extra information. And like I said, I'll talk about that in a little bit here, but we're just going to test this with SafeRequest. So, like I said, the output's like that, and we'll send the request to the same URL as we did before using SafeRequest. When you make a request in SafeRequest, it's going to return an response object. Response is also a class in SafeRequest, and it basically handles data for you. So if we send a request using the SafeRequest.request function to a URL, that will automatically return a response. And optionally, you can add a name value collection here that will be post parameters essentially, or they will work like that on the server side. I'll talk more about how that works later because technically they're not real post parameters. But every request you send with SafeRequest will technically be a post request because no matter what, there's always one piece of data passed, which is added by SafeRequest behind the scenes, and it is an authentication key. It is randomly generated for each request to verify that each request is unique and that a tool like Fiddler's Autoresponder, which you can see right here, is not able to trick your client. And you can't just like bypass your whole authentication system, your whole authentication scheme by hard coding the output. So I'll show an example of that in a minute, but we've made the request. So now we have a few variables in the request object or in the response object. We have add data, where we can basically add information with a string and a value. Data exists, which will tell us if data exists inside of what are the extra options that are sent from the server. So you can pass an array right here, like I said. That's what those functions both do. They add it to that little array of information. Encrypted auth is a string represented the authentication code that was generated, which is encrypted. You don't really need to use this ever, but it's just there. You can get data, which is getting it from the same place that this is adding it, and this is checking if it exists. Like I said, it's the extra information from the server. And then the main two ones right here, you're going to be paying attention to these three essentially. You have message, which is like the main one. Status, which is whether or not it was that little first variable was true or false. And raw is just the raw response. So we're just going to be talking about status and message for now. This is status. This is message, and then the third parameter would, like I said, be the array of values. So if response.status, that means the request was successful. So we can go ahead and write line response.message. Actually, you know what? Instead of doing that, we're just going to console.writeLine response.status and response.message, and we'll see why in a few minutes. But so now we should just see true and testing 1, 2, 3, and that will be replicating exactly what we did before. Oopsies, what's going on here? 1 second, let me try to figure this out. I'm not quite sure this is happening. 1 sec. Test.php, test. Okay. Oh, the servers, did I not save this or something? There we go. Okay, my bad. I was super confused there for a sec. Anyway, so now, if we go ahead and look at the newest one, we'll be able to see it's encrypted. Now you're going to notice that I typed in SafeRequest.notify proxy here. By default, if this line isn't here, any requests sent through SafeRequest won't actually show up, and I'll illustrate that right now. So we can see that our client receives the information, but it doesn't actually show up anywhere in here. And if you're wondering why, that's because I talked about this earlier, but Fiddler works by replacing the proxy. So in .NET, you can nullify the proxy in the web client, and it will, kind of break Fiddler's automatic HTTPS decryption. So usually you're not going to have this line here. You're going to keep it to true, which is the default value, but for testing purposes, since I want to illustrate what's going on and show you guys that in Fiddler, I'm just going to keep it as false. Okay, so we've seen that the data is encrypted. So I'm going to go ahead and run this twice, and we're going to look at the response. So let me just write this down somewhere. So that's the response one time. Let's go ahead and run it again. And we can see that the response is actually different this time, and that can be attributed to our authentication key I was talking about. So, like I said, the whole entire point of the authentication key is so that you can't actually hard code a response that will be accepted every time. So we're going to go ahead and test that to make sure it works now. So I'm going to go to the autoresponder, enable it, and you can see I have this right here. Let me go ahead, and I don't think this file actually exists. There we go. Okay, we're going to make a file called test.txt. Did that not get accepted? Why am I not seeing that? Okay, let me just delete this rule and add a new one. Oh wait, can I just... Okay, find a file, good. We'll make a new text file called test.txt, and we'll hard code that response and select that. So now when we send this response, Fiddler is going to intercept it and automatically respond with whatever data is in here, which was from one of the previous responses. So theoretically, in most cases, this would get accepted, but we can see that SafeRequest knows something's up and it says response authentication failed, which is, something that's built in that you don't have to do anything, and it'll automatically, just kind of handle things for you. If you want to see what raw looks like, I can show you that real quick. Oops. So you can see raw is the decrypted response. So I was talking about the encryption key or the authentication key a second ago. The way this works is the client generates an authentication key which is stored in memory, okay, and then it sends an encrypted version to the server, and it's expecting the server to decrypt it. So the only way to bypass this would be to basically in real time. You have to do this nearly instantly because you're trying to intercept the request. What you would do is you would I guess you do like some type of memory dump, or you try to debug the application and find the authentication key in memory, and then decrypt it manually. So you'd also have to find the encryption key in memory and then replicate the encryption scheme inside of SafeRequest, and then decrypt that, and then figure out what the request initially was by decrypting a previous request, and then rebuild the previous request with the new encryption key, and then re-encrypt that whole entire thing, and then return that to the client. So it wouldn't be an easy process. Obviously, as all managed application programming goes, um, your licensing is only going to be as secure as your client encryption as well. So proper obfuscation is important alongside string encryption and anti-debugging. But those are all up to you. Obviously, SafeRequest is just for encrypting network transmissions. So um, those are all the main things. Just to go into those other functions in the response class I was talking about, we can go ahead and return an array of information back to the client. So in PHP, you don't even have to initialize one. You can just kind of, just set keys and values as a variable. So I can just say, let's see, and here would be a key. So I can put maybe Penguware, and then this would be a value. So we can put best and like, I don't know, Amware equals Polak. Okay, so Penguware equals best, Amware equals Polak. Great guy, great cheat. Okay, so we're gonna go ahead and pass the array value as the third parameter, and we're gonna look at the raw response now, and then we'll look at how to get that data. So now we can see response raw contains some extra values. It contains Penguware and it contains Amware. So like I was saying earlier, anything you add there is just going to be added to the information separate from status and message, which will always be there no matter what. Obviously, you're not going to have the key status, you're not going to have the key message. Don't use those for obvious reasons. But anything else, you're not really limited. And then to retrieve that from the client, probably wouldn't do response.raw. You would do response.get data string. Well, this is the type of the data, so you can return integers, booleans, doubles, whatever it may be, and this will convert it automatically. But we're just getting a string, and let's just say we wanted to get the string best. We would put in Penguware because the key value for Penguware returns best. So yeah, you could do that. You can check if it has a key, so you can do response.get data, or a data exists, I believe it was, to check if Penguware even exists in the first place. You can check like that. But this should just say true, testing 1, 2, 3, best, and Polak. That is what should be outputted by this. And we can see that all works. And if we look at the actual request, as per usual with SafeRequest, everything is encrypted. And you may be thinking, well, what if I send parameters? Like I was saying earlier, you can, do a name value collection and post your own data. So how does that work? We'll go ahead and make a name value collection. We're gonna have to use like specialized generics, whatever the hell it's called. Oops, please. I forget what the namespace is called. Collection specialized. Okay. There's that. So we'll just go ahead and say test Justin equals cool. Oh, whoops. Gotta put double quotes. Gotta hate switching between PHP and C#. Anyway, so now we can pass test and see what goes down. So like I said, up to this point, we've only tested getting data. So how does posting data work? If we look at the information sent, we normally you would have your you would have your post parameters sent in like web forms maybe. As you can see, there's nothing here at all, and that's because the way that this works in SafeRequest is SafeRequest will automatically take any data you posted. It will encode it with JSON, and then it will encrypt that as a string and send it as the post body, which we can see right here. So even data that you just send to the server, not just data you're receiving, is completely encrypted. It's just fully end to end, and there are no gaps whatsoever in the transmission. Um, Now, to retrieve this information from server side, you can access it the same exact way. If you look at the code inside of the SafeRequest script, you'll actually notice that when SafeRequest is initialized, it will actually replace the post data with with the decrypted version. So we can access that string cool by just saying post Justin. So if I wanted to return the same information to the client, we could quite literally write r Justin equals post Justin, and then the array would contain a key for Justin, and the value would be cool because that's the value that we're sending to the server. So to confirm that, once again, same exact thing for the getData function, and now we should have the word cool at the end. And we do. So that's SafeRequest. I might work on a separate library to make a login system easier. But if you want to make your own login system with SafeRequest, you can obviously do that. You would need to know a little bit more PHP, so you can actually write the SQL execution and queries and all that stuff. But that's just how to use SafeRequest. Like I said, I would stress that it's also very important to actually protect your code using obfuscation, and like advanced obfuscation techniques, probably a paid obfuscator if you're going to be licensing and selling your software. Um, but that is SafeRequest. That is how you implement it. If you enjoyed and you think this is useful, maybe like the video. Feel free, if you're a developer, to submit contributions in the Git repo. There will be links to the NuGet package and the Git repository in the description. And my next video will probably be an HVH video. I did this because I did an announcement and people wanted to see a SafeRequest implementation. So, like I said, I'll probably do a video for the login system coming up, but it's just a lot to do in one video, so I wanted to cover SafeRequest itself first. And that's it for now, so I'll see you guys some other time.